Good afternoon. Thank you all for joining the call. My name is Tom Ray, and I'm a lead forecaster here at the National Weather Service office in Louisville, Kentucky. I've been here at this office for about 14 years now. And one of the things that I enjoy looking at is the history of tornadoes across the area and the climatology of tornadic activity. The Louisville office actually covers 59 counties, 10 of them in southern Indiana and 49 in central Kentucky. So that's the geographical area that we'll be concentrating on here today. Let me go ahead and full screen the presentation. There we go. So why are we looking at historical tornadoes in the first place? Well, it is important to keep in mind that tornadoes do happen, and of course we all know academically that tornadoes happen, but it's good to be reminded that a tornado can happen anywhere, in any part of the community. They don't just happen in Oklahoma, of course, as we know. They can happen here in our own backyards as well. I think it honors the memory of the people who were negatively affected by the storms. We want to remember those who have gone before us and who were perhaps very powerfully affected by these storms. I think it's worth remembering that that has happened to people who live in the area. It informs us of typical tornado behavior or climatology. So in other words, when do tornadoes happen? When's the most likely time of year for them to happen? When's the most likely time of day? It allows us to study how tornadoes act, especially in this part of the country, because a tornado may not act the same here as it might act in the Great Plains, for example. And remembering these storms serves as inspiration to be prepared for the next storm, because there will always be a next storm, there will always be more tornadoes in our future, and it's important that we keep that in mind. The picture in the lower left there, for example, that was a tornado in 2011 that went right through much of Louisville, went through Jeffersontown. Tornadoes that day hit Churchill Downs even, hit the backfield of Churchill Downs. So it's important to remember that storms are in our future. Here's just a small handful of some more significant tornadoes that we've had in the area in the past. Starting in the upper left, going all the way back to August 27th, 1864. A tornado moved right through the city of Louisville, and it's interesting, there you see on the map that red line indicating the tornado path, that the tornado actually went from northwest to southeast, which is a little unusual. Most tornadoes in this area come from the southwest or west and move to the northeast or east. But this one came in from a slightly different direction and hit the Third Presbyterian Church at what was then Walnut and 11th Street in Louisville. Unfortunately, it struck during Sunday services, and there were about 20 fatalities in the church. The city did an investigation of the disaster after it happened, and they found out that that building was actually really shoddily built. It actually didn't take much of a wind to knock it down. Going to the right, May 9th, 1933 was the Tompkinsville tornado. That tornado touched down just outside of town, and as you can see, it moved from southwest to northeast. The orange color of the tracks there on the map indicates that it was an F4 estimated. We didn't actually have the F scale back in 1933, but now that we do have the F scale and the EF scale, we're able to go back and look at newspapers and read other accounts of big storms, and we can give it a fairly good estimation of how strong we think that tornado was many years ago. And this is supposed to have been an F4. It killed 36 people in Tompkinsville itself and continued to move off to the, it killed 36 people along the entire path. I believe it killed 18 in Tompkinsville. But anyway, it continued to move northeast all the way into Russell County and did quite a bit of damage. On the upper right, April 3rd, 1974 is an infamous date in tornado history in the eastern part of the United States. That was the day of the super outbreak. Many tornadoes across the eastern third of the United States, including the only two F5 tornadoes that we have ever recorded here in the central Ohio Valley, in other words, central southern Indiana and central Kentucky. Two F5 tornadoes, and both were that day, striking Brandenburg in Meade County, Kentucky, and Daisy Hill, which is actually just across the river, although a different tornado, in southern Indiana. And then Louisville itself was hit by an F4 that started just southwest of the fairgrounds. Actually, we had a pretty strong wind gust here at the weather office. That was back when the weather office was actually at Standiford Field. Had a good wind gust at the weather office, and then the tornado touched down just north of the office in a mobile home park. Struck off to the northeast, hit the fairgrounds, destroyed some of the horse barns, took some of the roof off of Freedom Hall, crossed Interstate 65, and Went along Eastern Parkway and into the Highlands and over into the northeastern part of the county and was rated as an F4. It actually continued on into Oldham County as well. And then at the bottom center there is March 2nd, 2012. That's the Henryville, Indiana storm. There were only 8 tornadoes that day, but one of them was this EF4 that went through Henryville and several other southern Indiana communities. It was on the ground for 49 miles and averaged a forward speed of 60 miles per hour, and actually crossed the Ohio River and moved into Trimble County, Kentucky. So I think some of these tornadoes illustrate the fact that tornadoes do indeed hit cities. Louisville's been hit several times. Tornadoes do indeed cross rivers, even big rivers like the Ohio River. There was another storm in southern Indiana many years ago that went through New Albany, and that storm actually crossed the knobs to get into New Albany. So topography doesn't necessarily prevent tornadoes anyway. It can affect them, certainly. Also on this March 2nd, 2012 date, West Liberty, Kentucky was famously hit that day by a very strong tornado. That's over in eastern Kentucky in the hills, where they don't get as many tornadoes, but tornadoes can happen pretty much anywhere. Speaking of big tornadoes hitting cities, this was the March 27th, 1890 Louisville tornado. We're not exactly sure where it touched down. That red line on the map on the left side is the approximate path. That's the path that we really know of. It may have touched down, and probably did touch down, farther southwest than that actually. May have even touched down as far west as Harrison County, Indiana. Some more research needs to be done on that to determine that for sure. But at any rate, it did go through the west side of Louisville and west side of downtown. And again, there's the river, across the river. It just kind of nicked Jeffersonville, but there was damage on the Jeffersonville side. Crossed the river again, and just happened to aim right for the Zorn Avenue water tower, destroying several of the little statues that are up around the base of the standpipe. Did quite a bit of damage, caused quite a few fatalities. Terrible day. Here's an example of some of the damage that was done by that tornado. This was Baxter Square, or now it's called Baxter Park. And that was pretty near the epicenter of the worst of the damage of the tornado, and you can see how it tore down those trees there. This was Falls City Hall, and this was I believe it was a 3-story building. It was either 2 or 3 stories. And there were many fatalities in this building. As a matter of fact, in this building is one of the highest single building death tolls ever recorded in the entire United States. There was a mother-son dance being held on the 2nd story of the building. And when the tornado struck the building, that 2nd story collapsed into the 1st story, and then the entire building collapsed into the basement. And there were many, many fatalities, unfortunately, that day. And as the tornado proceeded, it went into the Tobacco Warehouse District, just west of downtown. Kind of like this picture, because you can see the word Louisville on that building on the right there. Did quite a bit of damage. Here's some more damage just west of downtown on Market Street. So that red area on the left side of the map is the tornado path from March 27, 1890. The little yellow sunshine symbol towards the right is where the Weather Service office was back then. So it just missed the weather office. But as you can see, it went right through the west side of downtown. The Columbia building there that just came into view, that's where the Weather Service was located. Columbia building is no longer there. Here's a few landmarks for the present day to give you an idea of what would be affected if this storm went through here today. The Slugger Museum was in the past. The Filson Historical Society was in the past. The Galt House not far away. The Government Center not far away. 4th Street Live not far away. If a tornado were to come through this area, maybe on a Friday night or a Saturday night, that could be pretty bad. And then I don't know how many of you noticed, but there is actually a memorial to this tornado on Main Street in downtown Louisville, to the 1890 tornado. And there's some pictures on it towards the base that you can see there. So what if this happened on the first Saturday in May? Or what if this path that this hypothetical path that I've drawn on the left side there, what does that happen? What if it went through Iroquois Park, Churchill Downs, the fairgrounds, not far from the airport, maybe going near Churchill Downs on Derby Day or Oaks Day or any day around those couple of weeks surrounding Derby? it's something we need to think about. It's something that the Weather Service has worked very hard on to increase public awareness of, and we also work with city officials and Churchill Downs officials to keep the public safe. Each year we have Weather Service personnel stationed at and near Churchill Downs to give weather information to the people who are in charge there so that the public can stay safe while they're enjoying the races. That picture in the lower right, I should say, the picture in the upper right with the tornado behind Churchill Downs, that's photoshopped, that's not real. It's a real photo, of course, but I put the tornado in there just to illustrate the point of what if this scenario happened, what would we do? And then the same with the lower right-hand corner. It's a real photo except for the tornado. I put the tornado in there. But it's something to think about. What if you're on Interstate 65 heading south, as this photographer was, and you see a tornado coming towards you? What to do, especially on I-65 since it's elevated. These are all just things to keep in the back of our minds. So moving on to our website, there's the URL there towards the top, weather.gov/LMK, or you can do /Louisville. That'll work too. And then again, tornado_climatology. So that will take you to this series of web pages. You see the different tabs across the top there. And this website at least strives anyway to list all of the tornadoes that we know of that have happened in southern Indiana and central Kentucky. So we have tornadoes on these pages going as far back as 1830. Of course, when you get back that far, you don't have a whole lot of information on the tornadoes. But we do our best to include all the tours that we know of. Now, before 1950, the only tornadoes that are listed here are those that were an F2 or stronger, or that resulted in a fatality. Post-1950 is when the Weather Service started keeping really good records. So post-1950, we have all tornadoes that we're aware of using Weather Service records. Now, it might sound fairly straightforward. A tornado happens, you plot it on the map, and you move on. But actually, there are problems with doing that sometimes. For putting these pages together, I consulted multiple sources to get the information. And sometimes those sources contradicted each other. And in some cases, those contradictions could be unraveled through research. I went to libraries in the area and I did newspaper research to try and figure out which source was giving me the best information and unravel that. Other times, the contradictions were just not able to be solved, and maybe someday in the future we'll figure some of those out. Now, as I said before, we don't have a good National Weather Service official database before 1950. So before 1950, I used Tom Grazulitz's Significant Tornadoes, and you see a picture of it down there in the lower right-hand part of the screen, affectionately known as the Big Green Book. So that Big Green Book has all those tornadoes that are F2 or stronger or resulted in a fatality, going back to 1680. Now, the oldest tornado that I could find in there for our area was 1830. But Mr. Grazulitz has every tornado that he could find of with those criteria back that far. It's an amazing work. And then maybe you see there on the cover, it says 1680 to 1991. He also did a supplement that takes it into the mid-90s. And I hear that he's working on another edition to have tornadoes since the mid-90s. So I'm excited about that. Hopefully that'll come out soon. Another issue with plotting historical tornadoes is vague descriptions. Sometimes a report will say, well, a tornado was near Milltown or northeast of Louisville. Well, that doesn't, it's not precise enough really to plot on a map necessarily. I don't want to plot things on a map and give an illusion of specificity that we don't actually have. Inexact latitude and longitude are sometimes given. Oftentimes they're only given to 1 or 2 decimal places back that far in history. So that doesn't narrow down quite enough to really plot it on a map with great precision. Sometimes I've found that county seats are used as a proxy for the actual location. I think this is particularly prevalent, for example, in Warren County, Kentucky. When I was plotting the tornadoes for Warren County, an awful lot of them were in Bowling Green. Now, that partly makes sense since Bowling Green is the large town, and so you would have reports and witnesses of tornadoes in the town. So there's some population bias there, and that's to be understood. But it just seemed awfully biased towards Bowling Green, and so I kind of wonder if maybe there were newspaper reports that said, well, there was a tornado Bowling Green, but actually it was maybe just outside of Bowling Green, somewhere else in Warren County. Most of the tornadoes that we plotted as a straight line between 2 points. But in reality, a lot of tornadoes don't do that, especially the smaller ones. They'll have bends and turns in their paths, or they'll pick up and put back down again, which is what the second bullet there addresses. Oftentimes, tornadoes aren't constantly in contact with the ground. They'll go for a while, maybe they'll lift up a few feet or a few dozen feet and then come back down again. Other tornadoes or other issues there in that third bullet, they're not at their maximum strength for their entire lifetime. So when we categorize a tornado as an F2, well, that F2 means that it was an F2 at its very, very strongest moment. It may not have lasted very long, it may have lasted less than a minute, but that's its strongest point, and so that's what we call it then. But in reality, that F2 tornado was probably an F0 for a while, then an F1 for a while, then got to F2, and then probably weakened back to an F1, F0. So it's a little misleading sometimes to look at a map and see a tornado color like that map that I showed for the Tompkinsville tornado a couple of slides ago. That whole line was orange because it was an F4 tornado, and orange was the color that I used for F4s. In reality, that probably varied in strength along that path and may have even lifted here and there as well. The next bullet, cyclic tornadoes are often recorded as a single long path tornado. So we read in historical accounts of tornadoes that were on the ground for 50, 60, 100 miles. And that's not impossible. That does happen sometimes. But oftentimes what will also happen is you'll have a supercell thunderstorm that will put down a tornado, and that tornado will last for a little while, and then it'll lift up into the cloud. But just as that first tornado is lifting back up into the cloud, a new tornado is developing and touches down just ahead of it. And sometimes it takes very detailed, careful ground analyses to really see those breaks and really know that there was two different tornadoes and not the same tornado. So oftentimes in old newspaper accounts especially, you'll get reports of tornadoes that were on the ground just forever and ever and ever. And in fact, probably a lot of those tornadoes did occasionally lift, or may have even been separate tornadoes that were just lumped together as one. Now, one little side note to that is the infamous tri-state tornado. The tri-state tornado was March 18th, 1925, and it touched down in central Missouri and is recorded as having stayed on the ground all the way to southwest Indiana, hundreds of miles on the ground, all the way across southern Illinois, all the way into Indiana. And so far, to my knowledge anyway, no researcher has been able to find a break in that path. And there have even been some fairly cynical researchers who would not have a problem at all of saying that this tornado was not just one tornado for these couple hundred miles, that it was actually multiple tornadoes. And even some of the more cynical researchers have not found breaks in this storm, and witnesses have been interviewed. There are not many witnesses left now, of course, from 1925. The witnesses have been interviewed, detailed analyses have been done, and the tri-state tornado, as amazing as it sounds, may have actually been on the ground for a couple of hundred miles without lifting. And as a matter of fact, some researchers have hypothesized that the tornado path for that storm is even longer than what we've accepted, that it may have touched down even farther west in Missouri. So some tornadoes do indeed stay on the ground for many, many miles. Some tornadoes weren't even given an F-scale rating. You know, when you go back enough decades and you need to rely on newsreels and newspaper reports and that kind of thing, sometimes it can be difficult just to give a tornado rating at all. Plus, we need to take construction into consideration, perhaps a home that was not as well built in 1920 or 1905 or something like that. And that has a bearing on how strong we determine that tornado to be. Like I was talking about the Third Presbyterian Church in Louisville, August 27, 1854. The church was destroyed. But if the church was poorly built, which it seems to have been, maybe the tornado wasn't as strong as you might initially think it was just by looking at how severe the damage was. And with some tornadoes just don't even hit much. Some tornadoes stay out in open fields or go through woods and don't hit a whole lot, and sometimes it's just not possible to give an F-scale rating in good conscience. And finally, other damaging winds mimic a tornado. You can have straight line winds out of a thunderstorm that can get to 100 miles per hour and can mimic a weak tornado. It can do the same amount of damage as a weak tornado. Sometimes it's a source of frustration for me as a forecaster that I think sometimes people don't take severe thunderstorm warnings as seriously as maybe they should. Well, it's not a tornado warning, it's just a thunderstorm. Well, true, it may not be a tornado, but severe thunderstorms still can knock down trees and damage buildings and can do a lot of harm and really do need to be paid attention to, just like tornado warnings do. That picture in the upper right corner, that was taken in Gravel Switch, Kentucky, April 3rd, 2018. And looking at that picture, gosh, it looks like a tornado. Looks like there might be a little bit of a wall cloud, a little lowering there, and then you can see the funnel illuminated by the lightning. But we never got any reports of any damage in that area. It's nighttime. It's pretty far away from the photographer. There's some trees in the way. So was it a tornado? Was it not a tornado? We're not really sure. Unless we get a report of something being hit and destroyed at that location and at that time, it's hard to say. So could that have been a little maybe ES0 tornado that touched down for a few moments? Sure, it's possible, but we may never know. So that's not in the database. And then things change sometimes as new information comes to light, and it's very important for us to have an accurate database. So at the top there, we see back to the super outbreak, April 3rd, 1974. On the left, we have a map of tornadoes that have hit Spencer County, Kentucky. And at the bottom of that map there, it's kind of hard to read because the print is small, but there's an orange line that comes in from the lower left and from the southwest and heads over towards Taylorsville Lake. And that was an F4 that happened on April 3rd, 1974. That tornado actually began west of E-Town, west of Elizabethtown, and made it all the way through Nelson County and went into Spencer County. And that was the best information that we had at the time that we were making this map, was that track. Well, then, a member of the public who saw that map and who lived through that tornado when he was a boy contacted us and said, hey, I've got some information for you that I think is helpful. I was in this tornado, and here's where I lived, and here's where my neighbors lived, and here's the damage that occurred at my house and my neighbors' homes. And I went out and I looked at the damage with my dad the next day, and here's what we saw. And so he gave a lot of really helpful and reliable information. And with his information, we were able to much more accurately plot that tornado. So on the right-hand map, you can see how wildly different it is. That tornado still comes in from Nelson County and from the southwest, but it goes up through western Spencer County and is quite different from what we had originally plotted. So thanks to that person coming forward and giving us more information, we could do a much, much better job of correctly plotting that tornado. Now, I should also give a little asterisk here. That it looks a little worse than it is. The portion of the tornado that is north of the other F4 tornado, that was the Bullitt County tornado, May 28th, 1996. That's that left to right orange line. North of that left to right orange line, the tornado was actually off the ground most of that time. It was very intermittent, and it was not F4 strength by the time it was that far north in Spencer County. It eventually hit Elk Creek and lifted just north of Elk Creek, but there was actually only very minor damage up there. And that's probably why we didn't have that information before. There was so much greater damage done by that tornado earlier in its path, especially in the Elizabethtown area, that's where all the reports centered on. So we didn't hear about this very minor damage at the end of the path in Elk Creek. And then below, May 18th, 1995, that was in Nicholasville, Kentucky on May 18th of that year. And at the time that these storms plowed through, which was about 7:30 in the morning, at the time that those storms moved through, it was determined that they were straight line winds, not tornadoes. And these storms actually moved through Chesapeake County High School right around the time that the school buses were arriving with students. And as you can see in that photo, it did a fair amount of damage to the school itself. It was significant. Well, there was some public outcry recently from people who were there, and they spoke to our MIC, that's meteorologist in charge, here at the office, and they were really, really insistent that it was a tornado. And you know, a lot of times we get people who say, well, it had to be a tornado, the damage was so bad. And that's not always necessarily the case, with all due respect. As I mentioned before, severe thunderstorms can produce very significant damage. So just because something is destroyed, it doesn't necessarily mean it's a tornado. But nevertheless, the people were really insistent about this particular storm, and so we decided to open an investigation. So this office went back and we looked at radar data, we talked to witnesses, we looked at photographs, looked at newspaper accounts. And after going through all that data, we decided that it probably actually was a tornado, not only a tornado, but probably an F2. So we've gone back into the database and we're working on getting that corrected. We want that data to be correct. It's important to us. So even if a tornado happened many, many years ago, we still want it to be right. All right, so back to the website. We'll go through the different tabs that are along the top there. So I have, for example, just a basic list. This is just a flat-out list of every tornado that's in the database. So there's the June 1830 tornado that I referenced earlier. And as you can see, there's not a whole lot of information for it because it was 1830. As we get more recent and into more modern tornadoes, there's much, much more information to be had. This was originally all one big long list, but then it got so long that I had to split it into two tabs. So I've got 1830 to 2006 in the first tab there, and then in the second tab from 2007 to present. Now I should say I'm a little behind in getting the tornadoes into this list. I'm still working on last year, so I have part of last year and some of this year to still get in there. Now, as I said before, I use multiple sources to get my information, and sometimes there are discrepancies among those sources. And I wanted to be totally transparent about all the discrepancies that I found. And so after each description of each tornado, I have the discrepancies that I found, and I spell them all out. I don't hide anything. So I understand that it can be frustrating to see these discrepancies and to maybe want an answer. And like, well, okay, which one of these is right? Sometimes it's hard to figure out which one of these is right. Also, it takes a lot of time to research a tornado, even just one, let alone many, to find which is correct. And I'm hoping that sometimes, like what happened with the April 3rd, 74 tornado in Spencer County, maybe someone will read this and see these discrepancies and say, oh, well, I was there, or I have pictures or something. I have some information that can help resolve some of these discrepancies. But many of the storms do have discrepancies, and they're spelled out here, so people are aware of that. And contact us if you have information on a tornado and it's good, solid, reliable information. Maybe you have some photographic evidence or some other kind of evidence that you can provide. Please feel free to contact us. If you see something that you think is wrong or needs to be plotted a little better, you can email us, you can call us, you can stop by the office if you wish. However you'd like to get in contact with us, we appreciate. Moving on to the next tab, I also have the tornadoes sorted by county. So here's Clark County, Indiana, and you can see all the different tracks there. The tornadoes are color coordinated by their strength. So let's see, are there any black? Yeah, so there are some black tracks down towards the bottom, down towards the south there. Those are the F0s. And then blue is the F1s, green is F2s, yellow is F3s, orange is F4, and red is F5. And in the upper left there in the northwest, you can see there's a red track there. That's one of those two F5 tornadoes from the super outbreak, April 3rd, 1974. That's the F5 that hit Daisy Hill and moved up through the northwestern part of the county, for example. And then the Henryville tornado is on here as well. It's the orange line that starts about halfway up the left-hand side and then moves to the right, to the east-northeast, crosses Interstate 65 and goes on out of the county. And that also came very close to the, well, actually that went through Daisy Hill as well, and did quite a bit of damage and resulted in several fatalities. And then along with each county map, I have a description of each tornado that struck that county. That's shown there on the right-hand side. And then actually, all the way down at the bottom of the map, there's the March 27th, 1890 F4 that we were talking about earlier that did so much damage in Louisville and hit the Zorn Avenue water tower and then grazed the riverside of Jeffersonville. Moving on to the next tab, I also have tornadoes organized by date. So any day that a tornado occurred has its own page, has its own map. There's a track map from May 30th, 2004. And then all the descriptions of the tornadoes along with it as well. Then I also have them organized by month. So we can look at all the May tornadoes, for example, that we have shown here. Right about in the middle of the map, there's an orange line that goes from Jefferson County through Bullitt and Spencer counties. That's the May 28th, 1996 Bullitt County F4. Looked at that a little bit earlier on that Spencer County map. And then once again, all of the tornado descriptions. In the lower right corner of those descriptions there's the May 9th, 1933 Tompkinsville tornado, 36 deaths along the path. And then I have them organized by season. So there's all of our winter tornadoes. Winter tornadoes are a little unusual, but as you can see, we do get them in the wintertime. And on the right-hand side, there's the descriptions of the tornadoes. Look at those in January there. And interesting to me, so those first two tornadoes are January 19th, 1928, and then the next two tornadoes are January 18th, 1929. So just kind of a funny little coincidence there that we had tornadoes on those dates in subsequent years in January of all times. And that first tornado there, January 19th, 1928, actually did hit Churchill Downs. So Churchill Downs has been hit a couple of times. And then I have them organized by year as well, of course. So here's 2011. 2011 was by far our busiest tornado year on record. If I remember correctly, I believe we had 60 tornadoes that year just in southern Indiana and central Kentucky. It was crazy. It's a very busy year for us here at the Weather Office. Fortunately, most of them were weak. The strongest tornado that year, I believe, was that EF3 that's showing up in southern Henry County. That's a couple of counties east of Louisville. There's a little yellow line there. It's kind of hard to see. But most of the tornadoes that year were fairly weak, thank goodness. And then I have some random statistics. That map in the middle is a map of all the tornadoes, again, color-coded. And then on either side of the map there, you can see some of the statistics that I have listed on that stats page. One thing that I was curious about when I made this map of the entire area was if there were any tornado alleys. A lot of people say, well, tornadoes follow this ridge line, or tornadoes don't go across the river, or Floyd's knobs prevent tornadoes, or make them turn a certain way. And there's really not a whole lot of evidence for that in the data. And looking at the map here, it's kind of hard to pick out where maybe more or fewer tornadoes occur. Maybe make an argument for a little bit of a tornado alley in southern Indiana from Perry County northeastward to Jefferson County. There's a pretty good concentration in there. Note that over Louisville in northern Jefferson County, Kentucky, there's quite a concentration of tornado tracks. However, that's a population bias. That's most likely because that's where the city of Louisville is. So there were lots of people to witness tornadoes. There were lots of people to report tornadoes. And there were lots of things to damage by the tornadoes. So that's probably a little bit of a bias there. It's probably not totally meteorological. Looking farther south to Warren County, as I mentioned before, see all those little dots right smack in the middle of the county. They're all clustered around Bowling Green. Maybe that's just a population bias once again, although Bowling Green isn't, of course, nearly as large as Louisville. But maybe a population bias, maybe it's real, not sure. And interestingly, if we look over to the east in Fayette County on the right side of the map, Lexington, the second biggest city in the state, really doesn't have a lot of a population bias. I was kind of surprised about that. There's really not a whole lot of tracks right through Lexington. If you go to the north, from Frankfort and Franklin County over to Scott County, there's quite a few tracks there. Lexington was missed by the super outbreak and has been missed by quite a few tornadoes, according to the data that we have. Some more stats. I have some graphs on there. How prevalent certain scales are. That graph in the middle is the total number of tornadoes that we have in the database for each year going back to 1830. You can see that real tall spike there on the right side of the graph. That was 2011. Looks like maybe 61 tornadoes. Looks like I was off by one there. And you can see how incredible that year was, how out of the ordinary that year was compared to all the other years. Now, it kind of looks at first glance, as we go from left to right through time on this graph, that tornadoes are maybe becoming more common. But in actuality, they're probably just getting better reported. And it's probably mostly reporting bias and detection. We can detect tornadoes now with our modern radar and other tools so much better than we could in years past. So it's probably just that we're seeing them more and we're hearing about them more. Now, I don't know if you can see the dates along the bottom there. The text is kind of small, but a lot of that increase in tornado activity happened after 1950. Remember, after 1950 is when the National Weather Service database really starts. So that's probably an artifact of that. I do have a special page on violent tornadoes, and we define violent tornadoes as EF4s or 5s. And I went ahead and did this for the entire state of Kentucky and the entire state of Indiana. And so all those tracks on there are the tornadoes. The red ones are F4s and EF4s. And then there's a couple of darker colored ones, almost kind of a reddish brown color. And those are the F5s. And there's the tri-state tornado from March 18th, 1925 that started in central Missouri and tracked all the way across southern Illinois and all the way into southern Indiana. And may actually have been one tornado. So let's move into tornado safety a little bit. I kind of like these graphics about before the storm and the difference between a watch and a warning. So a tornado watch, or a severe thunderstorm watch, or even a flood watch, those mean that the ingredients are there. They haven't been put together yet, but they're there. So we've got the instability in the atmosphere, we've got moisture, we've got a trigger coming in, like a cold front, for example, or some upper level disturbance is coming in to help spark off those thunderstorms. But it hasn't happened yet, but it should soon. So we put out the watch to let people know, hey, we may have some heavy weather a little bit later, be on the lookout. A warning means all the ingredients have come together. That instability is being realized, the moisture is creating clouds and storms, and that cold front or that upper level disturbance is here, and it's making those storms pop. So a warning means that there is actually a storm and you need to take shelter now. For tornado warnings, we try to get a little bit of what we call lead time. So we try to issue the tornado warning before the tornado actually happens. That's our goal anyway. So when a tornado warning is issued, the tornado may not actually be on the ground quite yet, but we're expecting it very, very soon. And the thing you need to do is to get to your shelter. You don't need to go out with your phone and film it, right? We need to get to our shelters. We need to stay safe. It's important to be weather ready. Check your forecast regularly at weather.gov/Louisville. Listen to your local news stations. If you don't have a NOAA weather radio, we certainly strongly suggest having a NOAA weather radio in your home and in your business. And in schools, public buildings, NOAA weather radios are very important because that information comes directly from us here at the National Weather Service. So if we're issuing a warning, as soon as we hit that enter button on our keyboard, it goes right to NOAA weather radio. And NOAA weather radio will sound an alarm to let you know that we've just issued a warning. The second bullet there says have a way to receive warnings. Actually, we should have multiple ways to receive warnings, such as weather radio, a phone app, watching our website. Some communities have outdoor sirens. Remember, though, that those sirens are only meant to alert people who are out of doors. If you're inside, if you've got the TV on, or you're making dinner or something like that in the kitchen, that the outdoor sirens really aren't designed for you to hear that from inside. They're really more for people who are outdoors, so that people walking down the sidewalk or in the park or whatever can get to a shelter. Have a plan for where you will go if a tornado threatens, and have that plan in place before the storm hits. Maybe do it this afternoon after this call. Think about what would you do if a tornado was threatening your home or your place of business. What if you're in the car? If you're a school bus driver, what if you're driving the kids to or from school? Have these things in mind and go over them with your family and go over the plan with your workmates so that you all will know what to do in a moment's notice. Another good reason for that, and for this second bullet here too, or this last bullet, have a designated lookout, keeping an eye on the sky, especially at schools and businesses. Not all tornadoes are warned, and we all know that, and it's our goal certainly to warn for every tornado, but that's just not going to happen. We do the best that we can with the tools that we have and with the position, the point where the science is, but sometimes a tornado is going to touch down real quick and it may not have a warning out in front of it. So it's very important for the public to keep an eye on the sky. If it looks like it's getting stormy, go ahead and seek shelter even if there's no warning out. Gotta keep an eye on things. Tornado safety during the storm. So this is, the warning has been issued, you gotta get to your shelter. Best thing, if you can, go to your basement. Many people don't have basements. If not, go to an interior room like a bathroom or a laundry room or a closet, something with as many walls between you and the outside as possible, particularly if there's no window. So that's why maybe an indoor bathroom or an interior closet, an interior bathroom or an interior closet is a very good choice. Stay away from windows. Years ago, we used to tell people to open your windows to equalize the pressure inside and outside the building. That was, we've done away with that decades ago, but I still hear every once in a while someone will tell you that you're supposed to open your windows. No. Stay away from the windows. if the tornado hits your home or your business, it'll open your windows for you. Stay away from the windows. Windows can break and shatter glass everywhere. It's not a good idea to be anywhere near windows in a tornadic situation. Large open span rooms like cafeterias or gymnasiums or auditoriums are not good places to be. Those roofs don't have a lot of support from underneath, and tornadoes can get up under that roof and collapse the roof. Churches oftentimes have issues with that. If there's enough advance warning, abandon mobile homes for a nearby designated shelter, preferably even before warnings are issued. And I know that's easy for me to sit here and say that. A mobile home is a tough place to be in a tornado. Mobile homes are not built to withstand tornadoes, even tied down mobile homes. It only takes an F2 or EF2 tornado to completely obliterate a mobile home. So we really like for people to, if they can, to get out of their mobile homes well before the storm hits, in case you need to go some distance to get to a suitable shelter. If you're outside in open country, try to find shelter inside a nearby sturdy building. If there's no building nearby and that tornado is bearing down on you, you may get down in your car and cover your head, or you may abandon your car and seek shelter in a nearby ditch or ravine. Neither of those are great options. You're in some trouble, whichever one of those you choose to do. Tornadoes can easily pick up cars and throw cars or knock cars over. If you're in a ditch or ravine, you could still be hit by debris, and you need to be aware of flooding and water rising in the ditch. So none of those are great options, so try not to be in that situation in the first place if you can at all help it. So Weather Ready Nation ambassadors, where do they come in? Well, that website there towards the top of the screen will give you a big, long list of things that ambassadors have done already, concrete actions that ambassadors have taken. That might give you some inspiration on things you can do. That first bullet there, you can start a dialogue in your community that will reduce the risk of being adversely impacted by storms and other extreme weather. Spread the word. Spread the word on safety rules and how to get information. And of course, we can work with our ambassadors. That's the idea. We're not sending out ambassadors just to do it all themselves. We're here to work hand in hand with the ambassadors to get that information to the ambassadors. And so the ambassadors can be force multipliers and get information out to the rest of the public. Talk about preparedness and resilience in your home, your office, your schools, community centers, your church, on your website, maybe on social media if you're on Facebook or if you're in Twitter. If you're in Twitter, retweet the posts that we put out, the tweets that we send about weather safety and incoming heavy weather. Follow us on Facebook. Spread the word, inspire others to take action, and so that everybody, because we can't talk to everybody ourselves here from the weather office, we need help. And so we need your help as ambassadors to spread the word about weather safety and how to get weather information. Here's a whole bunch of suggestions. We don't need to go through this whole list, but if you go to that website down there at the bottom, it'll give you all sorts of concrete actions that other ambassadors have taken in other parts of the country to help spread the word and get the word out to the public. I will say that bottom bullet there, join CoCoRaHS. CoCoRaHS, there at that website, CoCoRaHS.org, is a community of volunteers who measure rainfall every day. So a CoCoRaHS volunteer will have a rain gauge in their backyard, costs about 35 bucks. Put up the rain gauge, and then each morning that volunteer will go out to the rain gauge, see how much rain fell, if any, and then either through an app on their phone or through the website, then they submit the amount of rain that they had in their gauge. That's it. It's very simple. It's kept that way on purpose. It's very easy to do. I have a rain gauge in my backyard, and every morning I go out there and look at it and see if any rain fell. And if any did, I send in my report. And so we get those reports here at the National Weather Service, and many other entities look at those numbers as well. So joining CoCoRaHS goes a long way towards participating, being a participant in the whole weather enterprise. And then CoCoRaHS observers can, if they wish, also measure snow. They can measure snow liquid equivalent, snowpack liquid equivalent. Some observers even do evapotranspiration. So they have evaporation pans that they measure how much water is evaporating. That's all much more, it's more involved. You don't have to do all that if you don't want to. Just measuring the rain every day is fine. We have some schools that participate, some businesses that participate. Farmers, you know, very important information to farmers. People with gardens need to know how much rain they're getting regardless. And so as long as they have that information, might as well share it with the Weather Service and the rest of the world. All right, it